if this system functions as it should be.
Well, is this helpful to say that? I don't know. I would have to study more. But when you say equilibrium model, I kind of pull back because according to Menger, there's no such thing as equilibrium price, a unique monolithic price. There are always at least two prices, the offer and the bid price. And this means that the real model, which applies to our world, is a disequilibrium model. I'll have another lecture on that in this course later on. The disequilibrium theory of price. And the same disequilibrium theory prevails in the bond market. It's not an equilibrium, it's a disequilibrium theory. And by the way, that's the big point in our course here. Because basically what I am saying is that we have the wrong model here. We have the wrong infight within the community of the Austrian scholars. There is the time preference school and there is a productivity school of interest, and they are fighting like the religious wars at the time of Reformation. And this is fratricidal. You are fighting your brother and maybe killing him. There's just no need for that, because if you describe the bond market as a disequilibrium model rather than an equilibrium model, then you will have an offer price for bonds and the bid price for bonds, and they are different, and different forces form the offer price, and different forces formulate the bid price. And what you have to study is how they interact. And if you do, then the two theories, the time preference and the productivity theory, will merge and will be reinforced. And this is the solution. This is the new way of describing the origin of interest, a new theory of interest, which is answering most of the unsolved questions or unanswered questions which we have had so far.
We may just as well point to this model and add one more word here, or the axis may be renamed in the sense that this was our time axis, and we can rename this our productivity.
Is what?
Productivity axis, and then we have one model in which...
Well, that's a new idea. You work it out.
Yeah.
I mean, I haven't thought about that. This may be worth working out.
Yes.
Now, more questions? Well, in that case, I continue, because I still haven't finished this chapter, whatever, 5? Yeah. Chapter 5, which is the structure of the capital market leading up to... No, I'm sorry, this is chapter 6. This hexagonal model. And oh yes, I should have said that earlier. I'm sorry I wasn't able to finish. I have it in draft form, and my original intention was to include it in this handout what you have, and you may have noticed that chapter 6 is missing. Well, that's the reason. I just could not finish it in time to make it ready and available for you. So I'm sorry about that, but here it is. We can still have this lecture, and we can still have this discussion, which, by the way, I think was so far very useful. Now, you see how the improvement of the model has led us to this point, which I would say is a resting point, and the last edition was the merchant banker and his instrument, the gold bond. And as a consequence, we can talk about a gold bond market. And as all markets, whether you describe it as an equilibrium or a disequilibrium model, but all markets come up with a price, okay? Strictly speaking, it's an ask and bid price, but for the moment we can even forget about this distinction. The important thing is that we have developed this idea of how the capital markets work, and in this final step, the gold bond market appears. Now, this is very important because the gold bond market determines the rate of interest. Yeah? And the conversion from one to the other, in other words, the bond price on the one hand and the rate of interest on the other, is through a formula. Okay? Formula. Which formula gives you, it might be described as a machine. You feed in the market price of the bond, and it gives out the corresponding rate of interest. So you think of a standardized $1,000 bond. If you feed in the market price, you get the machine formula, gives you the rate of interest. And conversely, you feed in the rate of interest, it will give you the bond price. Now this machine, this formula is called the bond equation. So let me just give you a little story and then come back. This story is not about economics, it's about a book which a famous physicist in Cambridge by the name of Stephen Hawking.
Okay.
Yeah? This is the man with the Lou Gehrig disease. He's paralyzed and he can control a couple of fingers but not much more, and confined to wheelchair and so on, and still keeps lecturing in Cambridge, the chair which used to belong to Isaac Newton is now his. It's amazing because 40 years ago they gave him a year or less to live, and he still lives and works and writes books. And one of the books he wrote has the title, very interesting title, The Brief History of Time. Isn't that a wonderful title? I envy him for that. So, The Brief History of Time. And in the introduction of that book, Stephen Hawking says that he was trying to write this book without including a single equation. And then he gives the reasons. Because every single equation you put in a book will have the sales. And of course he wanted maximum sales, so that means zero number of equations, and then he gets the top income for this. Now, as it turned out, he included one equation, that's the famous Einstein equation, capital E is equal to mc squared. C is the speed of light. And yet the book sold millions and millions of copies. So his own principle actually turned out to his advantage, I think. Now, in talking about these things here in this course, I would say we are in the same position. At least one equation has to be included, and that is the bond equation. And the bond equation is the formula I was talking about, like the machine. You put in the bond price here, and out comes the rate of interest, or vice versa. You put in the rate of interest, out comes the bond price. However, I decided that I'm short of time, so I'm not going to give you the bond equation. If you are interested, privately I can give it to you, but I'm not going to include it in the course. You just have to take it from me on faith that there is such a bond equation, and it refers to gold bonds, which gives you this rigid mathematical, it's not a statistical relation, it's a strict mathematical relation between the price of the gold bond and the interest rate on the gold bond. And instead of writing down an equation which involves exponential functions and integration and so on, I describe it in terms of this play for that children gave, or seesaw. One child sits at one end, the other end of a pole, and there is a fulcrum in between. So up and down, up and down. And what this means is that when the rate of interest rises, the bond price falls, and vice versa. The rate of interest falls, the bond price rises. And the initiative could come from either side. You could say, the price of bond rises, that automatically means a fall in the interest rate and vice versa. That's all we have to know about the bond equation at this point, you see. So this is why all this talk, we talked about all kinds of things, conversion, exchange, wealth, income, annuitant, entrepreneur, inventor, all this talk, and it's diverse, right? We all agree. We covered a large ground, and interest as a word occurred only just a few times. But the whole thing is tied together with the bond equation, you see? So you have to build it up starting from the diagonal model, capital market, square, pentagonal, hexagonal model, which at this stage, the last stage, the bond market appears. And that gives you the rate of just one number characterizing the condition of the capital market. You see? This is, I think this is beautiful. You can tell me that I'm conceited, but I really think this is beautiful, how you build it up. And then one number, the gold rate of interest, the interest on the gold bond will keep the system together, okay? And then if you want to study the system in details, then you can always refer to the bond price. And then the variation of the bond price, which means variation of interest rate, comes in, you see? And then just how fast it changes and how it can get out of hand. And so all these questions, you go through the capital structure and the hexagonal model, bond market, rate of interest, okay? This is a simplification of a very, very complicated picture, but it's well justified and it explains a lot of things. So I'm offering it to you for what it is worth, and I'm hoping you will see my point that there has to be a theory of interest which explains all these very diverse features and explains it in a satisfactory way. So I still have 5 more minutes and I opened the floor for questions or comments or criticism.
Nobody has lost us so far in the purpose and the usefulness of this model, either under a gold standard or under a fiat system. No more questions?
Well, then let's have a conversation.
Sure, yes.
You must have a question.
Well, I was going to say I can write down the bond equation for you for the benefit of everyone. But
You will?
Here we go, because I will not be so kind tomorrow because I will do an exercise on that.
Will you write it down tomorrow?
I'll do it tomorrow. Shall I give you nightmares by writing it down today?
Yeah. Oh, we are so anxious to get it.
Okay, well, this is very simple, and Louis, you know this. You are absolved. The accountants and the bankers amongst us will know this. It appears in many forms. But this is, I think, what the professor is referring to.
Is that 1 plus I?
1 plus I. Minus t.
What is I?
The interest rate. The rate. Could be a discount rate, could be an interest. Sometimes it appears as a over 1 plus I.
What are P, A, and T? T is the duration?
This is the price or the net present value. This is the cash flow or the annuity. 1 plus I is self-evident, and T is the periods. The time periods, but because this is sometimes the same, it is expressed as what is this?
Reciprocal.
Reciprocal. So this is too much work for me. I express this as a minus T.
Period meaning the duration of the bond?
Yes. This is the cash flow or the annuity, the monthly cash flows, and then the present value. So if I is changed, then obviously this will have an effect after everything that's changed. Here will have an effect here because of the equal sign. That's the seesaw.
T is not the duration. T is the length of time.
Louis, I know. I'll make it simple.
We call it duration. It's not duration.
Now, if t goes to infinity. In other words, these are known as consonants.
Perpetuity. Okay.
Or the American jargon is how do the Americans call console? Console is a bond which never matures.
I've never heard of such a thing.
Oh, there
Other than
were
the British.
consuls in Britain.
Yeah, the British, I've never heard one in the US. I don't know.
No, yeah, you are right. In the US, they never existed. In other words, they never were traded. But the British government did issue consuls, and that's the name. Could you write on consul?
Consul, yes, of course.
So it just so happened that in the American literature, they didn't like the word consul for some reason.
No.
Yeah. No, I think there is an E.
I think there is an E.
I think there is an E.
I think there's an E, yes.
Okay. So the American literature refers to these as perpetuals, which says more than the word consul, but it's the same meaning. These are bonds which never mature. So you buy it, and for infinity it keeps paying. But infinity, of course, means as long as the government exists. If the government goes belly up, too bad, your consul loses its value. But the point is this, it's not a stupid idea to buy a consul. I tell you why. Because there's a market for consuls, and this market creates a value, a price for the consul, and that translates into an interest rate. And this is like a benchmark, you see, because if you sell bonds with 30-year maturity, this gives you one interest rate, and then other bond for 10 years maturity gives you another interest rate. So that's confusing. But there's a benchmark, and this is the consul rate, and it's useful to have a benchmark. But under the conditions of irredeemable currency, it just makes no difference whatever to have consuls. Nobody would touch it with a 10-foot pole, in fact. So there it is. Okay, thank you, Peter. Now, I must say about your bond equation, I'm not familiar with this version, and I cannot. But I don't want to start a controversy or anything. So let's just agree that there is a bond equation, and it has what I call asymptotic version, which is if the maturity goes to infinity, the equation is still there and in a very simplified form. Now that's known as the yield curve. Okay, it has an asymptote, a horizontal. Did everybody hear the name of this animal?
Yield curve.
Yield curve.
So this is.
And the horizontal axis is the time to maturity. And the vertical axis is?
It's the rate of interest.
The rate of interest. And as the time to maturity increases, the interest rate goes up, but it's limited with an asymptote.
To the rate of the consul, of the perpetuity, which is 1 over.
So it's approached arbitrarily closely but never reached this horizontal asymptote.
What is it? I can't read that. 1 over what?
I think 1 over I is the.
Perpetuity.
Yeah, that's perpetuity. I
Yeah.
thought I forgot about it, but I keep
1 over
it.
1 over I is what?
So the point is that the bond equation has an asymptotic version, which, if you like, is a simplified version, which may or may not be available in practice. Certainly today it's pretty meaningless because of the inflation, and therefore there will be no console market. Nobody in his right mind would buy a console when the value of money is disappearing. And but the point is that under the gold standard there would be a market for consoles. We know it from practice because Britain ran a very successful console business. All right. Now, time is up, so we adjourn. Tomorrow morning, Peter...
we just Googled bond equation, and you go to moneychin.com and it gives you the long form with all the stuff if anybody wants to see this.
Okay, that may be a different one from the one I'm going to use tomorrow. I think the mechanics will not be involved.
Well, it still doesn't look familiar to me. I would have to stop. So anyhow, okay, we call it a day and continue with Peter's kind of summary.
Tomorrow we reconvene again at 10 o'clock. I will briefly summarize and visualize the model on the large screen, and I will do a few exercises, but very simple exercises, on what the interest rate changes are going to do to your balance sheet.
Okay.
And that's for tomorrow. And then you will have proof positive that this is not very abstract, but very, very real.
Very real. Well, we are looking forward to your presentation tomorrow. Thank you very much.
Thank you.